Hello everyone, you are on the channel Who Created It and How. Today we're taking a journey through time to explore one of humanity's oldest obsessions, the moon. How did our ancestors, without the fancy telescopes and spacecraft we have today, gaze up at that silver orb and try to understand it? Let's find out. For thousands of years, the only tool humans had to observe the moon was the naked eye. And honestly, it's a pretty good tool. Ancient civilizations across the globe meticulously tracked its phases, from the sliver of a new moon to the bright, full disk. They noticed its regular, predictable cycle, which became the basis for some of the earliest calendars. Think about it. The lunar cycle, roughly 29.5 days, helped our ancestors plan for hunting, planting, and harvesting. It wasn't just a light in the night sky, it was a clock and a calendar, a guide for life itself. Ancient observers also saw more than just phases. They saw a face, a rabbit, a man or a woman carrying a bucket of water. These patterns, which we now know are vast plains of dark volcanic rock called Maria, sparked countless myths and legends. The Rorschach test of the sky, if you will. These stories, passed down through generations, were humanity's first attempts to make sense of the lunar landscape, to give it character and meaning. The real game changer arrived in the early 17th century. While not the inventor of the telescope, the Italian astronomer Galileo Galilei was one of the first to point a refined version of it towards the heavens. What he saw in 1609 forever shattered the old view of the moon as a perfect, smooth celestial sphere. Imagine being Galileo. You look through this new contraption and suddenly the familiar face of the moon resolves into breathtaking detail. You see mountains, casting long, dark shadows across the lunar surface. You see vast, deep craters, pockmarks from ancient impacts. Galileo's simple, handcrafted telescope revealed that the moon was not some ethereal, divine object, but a world in its own right, with a rugged, textured landscape much like Earth's. He meticulously sketched what he saw, and his drawings, published in his work, Sidereus Nuncius, or the Starry Messenger, caused a sensation across Europe. People were seeing the moon as a real place for the very first time. Galileo's work kicked off a golden age of lunar observation. Astronomers across Europe began building bigger and better telescopes, each eager to map this new world. In the mid-1600s, astronomers like Johannes Hevelius and Giovanni Riccioli created some of the first detailed lunar maps. It's fascinating how they did it. They would spend night after night, patiently sketching the moon at different phases to see how the changing sunlight revealed different features. Hevelius, in his Selenographia, named the lunar features after terrestrial mountains and seas, like the Alps and the Apennines. Riccioli, on the other hand, started a tradition we still use today. He and his assistant, Francesco Grimaldi, began naming the craters after famous astronomers and philosophers. That's why we have craters named Copernicus, Tycho, and Plato. They were literally creating a who's who of scientific history on the face of the moon, a tradition that continues with the International Astronomical Union. These maps weren't just pretty pictures, they were serious scientific documents, the first guidebooks to our nearest celestial neighbor. As telescopes improved through the 18th and 19th centuries, our view of the moon became even sharper. The debate raged. Was there life on the moon? Some astronomers claimed to see signs of vegetation or even cities. Franz von Gruithuisen, a German astronomer in the 1820s, famously announced he had observed a great lunar city with walls and fortifications. Of course, we now know these were just tricks of light and shadow on complex crater formations. But it shows how much people wanted to believe that we weren't alone, that this world next door might have its own inhabitants. The next great leap in lunar observation came with the invention of photography in the mid-19th century. Finally, astronomers no longer had to rely on their subjective and often imperfect hand-drawn sketches. The first successful photograph of the moon, a daguerreotype, was taken by John William Draper in 1840. It was a grainy, indistinct image by today's standards, but it was revolutionary. Photography offered an objective, permanent record of the lunar surface. As photographic technology improved, so did our lunar images. By the late 19th and early 20th centuries, large observatory telescopes could capture incredibly detailed photographs. Astronomers could now study features in minute detail, compare images taken years apart to look for changes, and create even more accurate maps. These photographic atlases became the essential tools for planning the next, most audacious phase of lunar exploration. Actually going there. And that brings us to the space age. In 1959, the Soviet Union's Luna 3 probe did something no human eye or Earth-based telescope ever could. It flew around the moon and photographed its far side for the very first time. For all of human history, one half of the moon had been a complete mystery. Suddenly we saw it, a landscape even more cratered and rugged than the near side, with very few of the dark Maria. It was a stunning revelation, proving the moon was not the same all the way around. Then came the Apollo missions. Before sending humans, NASA sent a series of robotic probes, the Ranger, Surveyor, and Lunar Orbiter series, to get an up-close look. The lunar orbiters in particular mapped 99% of the moon's surface in high resolution. These were the maps that allowed mission planners to pick the safest and most scientifically interesting landing sites for the Apollo astronauts. And finally, from 1969 to 1972, 12 humans walked on the moon. This was the ultimate form of observation. Astronauts didn't just look. They touched, they walked, they drilled, and they collected nearly 400 kilograms of lunar rocks and soil. For the first time, we had ground truth. We had physical samples that could be analyzed in labs back on Earth, unlocking secrets about the moon's origin, age, and geological history that we could never have learned from a distance. The observations went from passive gazing to active, hands-on science. Today, our observation of the moon continues with a fleet of sophisticated orbiters from various countries, like NASA's Lunar Reconnaissance Orbiter. These spacecraft are mapping the moon in unprecedented detail, using lasers to measure topography, spectrometers to analyze mineral composition, and radar to search for water ice in the permanently shadowed craters at the poles. These modern observations are paving the way for the next chapter, returning humans to the moon and perhaps one day building a permanent base there. So from a simple upward glance to a global network of robotic explorers, our way of seeing the moon has evolved dramatically. But the sense of wonder remains the same. Every time we look up at that familiar, silent companion, we're connecting with a story of human curiosity that stretches back to the dawn of our species. Thanks for joining us on this journey through the history of lunar observation. If you enjoyed this, don't forget to like, subscribe, and hit that notification bell so you don't miss our next exploration into who created it and how. See you next time.